The absolute one thing that you must know about bearings is that they're a direction. That's what they are. They tell you a direction. So it doesn't matter if it's a true bearing or a compass bearing, the two different types you need to know. They are both just telling you a direction. All right, so welcome to this particular lesson. We're going to cover, as is no surprise, bearings, the two different types. So you need to learn how true bearings work and also how compass bearings work. Yeah, but it's true. In either case, what they're going to tell you is a direction that something is traveling in. So let's just get straight into it. I'm trying to keep this brief without too many ramblings. So with true bearings, let's say we've got, here we go, there's some sort of object out at sea. Let's call it a boat, ship, whatever it happens to be. And let's have this boat. I'm going to start off my diagram with a north-south line. And let's say this particular blue blob is going to travel in a direction of, let's go 120 degrees, capital T. Capital T stands for true bearings. And let's try and make this remotely legible. That would be great. 120 degrees. Okay, so the idea with the true bearings is we've got this blob. He's right there. And he starts off facing due north, right? That's the way he's looking. We're looking down from above. He's facing due north. Now, if this blob wants to go in a direction of 120 degrees, what he needs to do is rotate clockwise 120 degrees. So he's not moving yet. He's just turning. So he's going to turn. There's 90. Let's keep going here. About 120 degrees. This looks about it here. He's rotated 120 degrees, so he's now still standing, floating, flying, whatever it happens to be, in the same spot, but he's now looking this way. And, we'll have him travel along in this bearing. So this is where the blob's going to go. He's heading down in this direction. The bearing, 120 degrees, capital T, told us what direction he was going to travel in, which sort of appears to be in a slightly, southeast type direction. Traveling along in this direction, here he is, he's down here now. He ended up traveling, in this direction here, and he ended up down here after traveling for so long. That's how true bearings work. They just tell you what direction they travel in. Let's have a quick look at another example. Here we go, new blob, here he is, and he's going to travel on a bearing of, let's go 225 degrees. Okay, this is his direction. All right, so we're looking at the blob from above, and he's going to walk off in a direction. I've now got him walking, by the way. So let's start with our north-south line. For true bearings, north-south is the only thing you absolutely must have. The east-west lines are kind of optional, at least for most questions. Yeah, I'll throw it all in anyway. Okay, north-south, so sort of like never eat soggy Weet-Bix, from primary school. All right, so this blob's traveling in a direction of 225 degrees. So what's that going to look like? Again, blob starts facing due north. This is the way true bearings work. And the blob's going to turn clockwise 225 degrees. Let's start rotating him. 90 degrees, 180, 225. Right, we're at 180. Let's get an extra, there we go, 45 degrees further across. This is the rotation. Blob's now facing this direction. So this is the direction blob will be walking in. And he eventually at some point gets to his ending destination. So this was 225 degrees as a rotation. And, as always with trigonometry, you need triangles. And what you would then do is turn our diagrams into triangles, right? So, in this case here, you would just bring him back to the north-south line. Bam, you've got yourself your triangle. This ended up being 45 degrees in here. And then you'd have to answer some sort of a question. based on it. You know, how far south did the blob travel? How far east did the blob travel? You know, they'd have, you know, some sort of question you have to find. And they'd probably tell you, you know, how far he walked. They'd give you like a distance here, for example. So these are the sorts of questions. This is how the true bearing works. Now, for the compass bearings, again, they're just giving you a direction. That is all a bearing is. The way the compass bearing does it is with this. Let's say, for example, blob, here he is. I'm going to, just before I even look at a question, I'm just going to draw up north, south, and I'll do east and west as well. Compass bearings do the whole thing, right? Don't just do north, south. We saw the last one with true bearings. You can kind of get away with just having a north-south line. For compass bearings, draw up the whole compass axes. All right, so let's say we've got our compass bearing for the blob, which will be north 50 degrees west. This here is how a compass bearing will look. The first part of the bearing will be either an N or an S, representing for north or south. Is this blob traveling in a northern direction or in a southerly type direction? Well, that's what the first letter will tell you. Okay, so it says north. This blob is traveling somewhere north, so somewhere upwards. But it isn't just north, right? If it was just this, N, well, that would mean it's traveling due north. The blob's traveling straight up. We can see, yes, it was traveling north, but not due north. It was actually, there's a 50-degree rotation to the west. So the way this compass bearing would work for our blob is, he's starting to face north, because that's the first thing, but then there's a 50-degree rotation to the west. So we're just going to rotate 50 degrees, bang, to the west. This is actually the direction the blob's going to be traveling in. So he's going to travel along in this direction. And that there is it for compass bearings. Let's look at one where the blob's going to head to the south, just so you can see what it looks like. Although a lot of you are probably already going to know. North-south, east-west, right? Never eat soggy Weet-Bix. If you're not in Australia, you probably have no idea what Weet-Bix is. I don't know. I actually don't know where Weet-Bix is consumed outside of Australia, but we definitely eat it here. So let's say we've got this compass bearing of south, let's go 72 degrees east. Okay, so in this case, blob doesn't start off facing north now, starting off facing south, right? And if it was just the S on its own, he would be traveling due south, straight down the map, so to speak. But it wasn't due south. It was definitely in the south direction, but there was a rotation 72 degrees east. So from our starting direction of south, we're rotating 72 degrees to the east. So rotate 72 degrees, and this is the direction that blob travels in. And remember, always, if you have a bearing, doesn't matter if it's compass or a true bearing, all they are telling you is a direction something's traveling in. So in this particular case, that is where blob is. And, you know, if there was some sort of a follow-up question that involved trigonometry, you know, obviously bring it back to the north-south line, you've got yourself your right-angled triangle. Or alternatively, you may be thinking, well, could I have brought it up here into the east-west line and created a triangle this way? You are absolutely right. You know, and not only that, like, you could just as easily find, you know, either of those missing angles. You know, here you got 72 degrees. This is obviously adding up to 90. You know, there's different ways you can find your angles still. But that is how the two bearings work. What I will say just before I sign off with the compass bearings is you always start with the north or the south. So like you certainly could have the perspective of this one where, you know, to go in this direction here, you know, maybe he started off facing east and then you have him rotating, like in this case, the 18 degrees you need to the south. That's not how compass bearings work. They start from either north or south. Is this object going upwards or downwards? And then rotate it either east or west as required. All right, guys, hope that made sense. And best of luck with your bearings / trig questions. All right, thank you.